Hi everyone. In physics, no matter how beautiful a theory may seem, at the end of the day it must face the harsh truth of experiments. That's exactly why Peter Higgs had to wait until 2013 to receive his Nobel Prize, even though his quantum field theory was mathematically elegant and refined. In the end, empirical evidence is what breathes life into theoretical ideas drawn on paper. But here's the thing. A big part of science still hinges on belief. Sometimes, no matter how brilliant your theory is, people won't accept it. In fact, some will go out of their way to discredit you, even if it means inventing bizarre arguments. Back in 1859, the astronomer Urbain Le Verrier observed something strange. Mercury's orbit didn't quite match what Newton's laws predicted. According to Newton, the planet should follow a closed elliptical orbit, meaning that Mercury should trace the exact same path again and again. Imagine the sun standing still. Mercury's orbit, year after year, would perfectly overlap, like drawing the same circle repeatedly. But in reality, that wasn't the case. Le Verrier noticed that Mercury's orbit precessed. It shifted slightly with each revolution. He measured a 43 arcsecond shift per century, which translates to just 0.012 degrees on a 360-degree circle. Tiny as it was, over time, it added up. After around 3 million years, Mercury's orbit would resemble a flower pattern rather than a closed ellipse. The real problem? Newtonian mechanics couldn't explain this. But back then, Newton's legacy was practically sacred. His laws were seen as unshakable truths, so scientists believed something else must be at play, perhaps an unknown planet inside Mercury's orbit, tugging at it gravitationally. Then in 1915, Albert Einstein introduced his general theory of relativity, which described how space and time could bend in the presence of mass and energy. Through his calculations, he showed that gravity wasn't just a force, it was a warping of space-time itself. And that warp? It explained Mercury's orbit perfectly. Newton's equations still worked fine in most cases, but Einstein introduced an entirely new layer of understanding. And more importantly, his predictions matched reality. Still, skepticism lingered. Many scientists remained firmly attached to Newton's worldview. One of them was Charles Lane Poor, a professor at Columbia University, who outright called Einstein a dreamer and his theory a mathematical joke. To him, Newton's laws were the absolute gold standard, immutable and beyond reproach. Then came 1919. Arthur Eddington organized an experiment during a solar eclipse to observe how starlight bent around the sun. The results were clear. Light really does bend due to gravity, just as Einstein had predicted. Faced with this, Lane Poor still claimed the data had been fabricated, insisting Mercury's orbit anomalies were caused by a mystery planet, not warped space-time. He went so far as to accuse Einstein of deceiving the public. Space-time curvature? That, he said, was the language of poets, not physicists. Later, Max Planck famously said, "A scientific truth doesn't triumph by convincing its opponents, but because its opponents eventually die, and a new generation grows up familiar with it." That may sound a bit harsh, but it's not far from the truth. This story is a perfect example of how rigid thinking can exist even in science. Belief, once deeply rooted, is incredibly hard to change, whether you're a regular person or a tenured professor. And really, this applies to everyday life too. Some people learn from a single mistake. Others have to hit the wall again and again before they finally realize what's going on. Throughout history, science has always struggled against prejudice and dogma. Just look at the people who still believe the Earth is flat. Not sure they truly believe that. Maybe they're just skeptics by nature, questioning everything. But their existence proves one thing: belief is powerful. Sometimes it drives progress. Other times it blinds us. Let's go back to Einstein. The 1919 eclipse experiment made him a superstar. For the first time, a scientist was more famous than movie stars or pop icons. Still, here's the twist. In 1921, Einstein received the Nobel Prize, not for general relativity, but for his work on the photoelectric effect. which he had discovered back in 1905. It was one of the most controversial decisions in Nobel history. Why didn't he get it for relativity? One key reason was Alvar Gullstrand, a senior member of the Nobel Committee. He called general relativity impractical and unprovable. When asked if Einstein might ever receive the Nobel for relativity, he said, "Einstein? Adamantly. He will never win a Nobel Prize for that, even if the entire world demands it." In fact, in 1921, the Nobel Committee chose not to award a physics prize at all, claiming no worthy candidate. But by 1922, facing enormous public pressure, they had no choice. So they awarded Einstein the 1921 Nobel Prize, 1 year late. That year, 2 prizes were handed out, one for Niels Bohr and the other for Einstein. But the committee still refused to honor general relativity. Instead, they went back 16 years and dug up the photoelectric effect. As a quiet protest, Einstein didn't even attend the 1922 ceremony. Traditionally, Nobel winners are invited to give a lecture on their research, a chance to explain their scientific contributions and celebrate the achievement. But since Einstein missed the event, he gave his lecture in 1923. And what did he talk about? Not the photoelectric effect. Instead, he gave a lecture on general relativity, the very topic the committee had rejected. This move only deepened their resentment. Many believe that's one reason why Einstein never won a second Nobel Prize, even though relativity has been confirmed time and time again. Truth is, Einstein's influence on science rivals that of Isaac Newton. Many scientists agree he deserves to be called the second Newton for the revolutionary breakthroughs he introduced. Still, like Max Planck said, a scientific truth doesn't always win by changing minds. Sometimes it only prevails when the old minds pass on and the new ones grow up in its light.